Alrighty, so let's go ahead and take a look at the third page of the review. So I have another proof here, and remember, don't just jump into this. Take a look at what's given, mark everything down, and then see what's not given because the picture already provides it for you. So let's take a look at segment MO. MO bisects angle LMN, okay? So here's segment MO. And angle LMN is right here. This is the angle, okay? M is the vertex, and of course, we are referring to this angle here, okay, that measure. And then notice that angle L is congruent to angle N. So angle L and angle N are there. All right, let's go ahead and mark things. What does the bisector do to this angle? Remember, it splits the angle into two congruent parts. So that means that here is angle LMN. This and this are congruent due to the fact that this bisector is going to split that angle into two congruent parts. And then notice that we have angle L and angle N. They are congruent because that's given. It doesn't tell us why they're congruent. It just says that it's given. So we're just going to assume that it's true. Okay? So, and now we have these two triangles. They share a same side over here. That's what we call the reflexive property, right? So this is the reflexive property. So do I need to mark anything else? This is how I'm thinking before I jump into the proof. Are there any parallel lines? Are there vertical angles? Are there anything else I need to know? I don't think so. So it looks like I'm okay. So I can jump into the proof right now. So writing the first thing, it should be segment MO is bisecting angle LMN. And we know that from the given, angle L is congruent to angle N. And that's just going to be given. Okay? So here, well, this is angle LMN. Because of that bisector, right, it splits the two angles into two congruent parts. This right here is labeled as angle 1, and this right here is labeled as angle 2. Angle 1 are congruent, angle 1 is congruent to angle 2, and that's because of the definition of angle bisector. And then notice that we have a reflexive property here because they both share the same side. So I can just say segment MO is congruent to segment MO. And that's because, again, reflexive property. Okay? And hopefully at this time, you know how to look at your picture and look at what's given before you jump into the proof. Okay? If you notice something with the triangle proofs, you need to see if there are vertical angles, you need to see if there's reflexive properties, you need to see if there are any parallel lines cut by a transversal, then you can go ahead and jump into the proof, right? And don't forget, again, you look at your given and mark what's true from there, okay? And then you'll be successful in doing these type of proofs. And let me tell you, when I was in high school, guys, I did not know how to do any of these until I started teaching, okay? So that's the approach that you should, look at. I didn't have any tips when I was doing these proofs. So here are my tips. Hopefully that you'll get better at, in doing this so you can be successful for this next test. Okay, here we go. What else can we write here? So look at what's proven, or what we're trying to prove. Notice that we're not trying to prove that the two triangles are congruent. Well, we'll eventually show that in this proof, but our last, statement here should be segment LO is congruent to segment NO. So this is a CPCTC type of situation here. So we can go ahead and take a look at these two triangles here. I notice that I have one arc here and one arc there. I'm going to write angle. I have two arcs here and two arcs there. Sorry, I should write an angle there. So I have 2 arcs here and 2 arcs there. I should write angle and an angle. And they both share a side, so I'll write side. Okay? So what do I have? I have an angle. Oh, wait. Oh, my bad. Hold on. I'm going to write it the other way. I have an angle, angle, side. And then over here, I have an angle, angle, side. So what does that mean? These two triangles are congruent. So we can say triangle LMO is congruent to triangle NMO. And that's because of the angle side postulate, right? And if you're having troubles writing your congruency statement, start with whatever you want and then close it, right? So here's what I mean. Angle L, sorry, no, not angle. LMO, close it. That's your triangle. So I write LMO. Okay, you can say OML and then close it, but you need to make sure that what you're going to write after that, they correspond. So angle L has 2 arcs, and so does angle N. So N should be in the first position of what you're writing. And then angle M, they both have 1 arc, right? So here's angle M, and the other triangle has an angle M too, so they both should be in the middle. And then lastly, O is right here. So NMO, LMO, they both share this point here, or this angle here, or these 2 angles there, I don't know. All right, so AAS, and then the last one, segment LO, is congruent to segment NO, and that's because of CPCTC. Okay? Alrighty, so let's go ahead and take a look at this triangle. I need to figure out the measure of each numbered angle. Alright, number 19 says angle 1. Angle 1 is right here. So use your pink sheets for this, because if I have a triangle with 2 congruent sides, then that means that the angles opposite to those 2 congruent sides are also congruent, right? I have a congruent mark here, or if I have 2 tick marks here and 2 tick marks here, they're congruent. That means the angles opposite to those congruent sides are congruent as well, okay? So mark them. This and this are congruent. So I put 66 degrees, okay? And then we know that, so let me put 66 for angle 1 here. Okay, so I need to figure out angle 3. Because I know the sum of interior angles of a triangle is 180, can't I just do angle 3 is basically 180 minus 66 plus 66, or you can just say 180 minus 66 minus 66. It doesn't matter. It's the same thing. So basically, that should give you 180 minus 32. Remember your order of operations. Oop, that should be 132. 132, because 66 plus 66 is 132. And then I can do 180 minus 32, which is 48 degrees. So here, this is 48 degrees. So number 20 is 48 degrees there. Okay? Alrighty. I can figure out angle 4. And remember, there's something that you need to know, right? This is what we call a linear pair, because these 2 angles share a side, right? So if I can do a linear pair, all I need to do is, well, this is 180, right? So I can figure out what angle 4 is. Angle 4 is equal to 180 minus 48. And that's going to give me 132. So angle 4 is 132. Okay. So now I need to figure out what angle 2 is. So I have 24, 132, but I don't have an angle 2 here. We know that the sum of the interior angles of a triangle is 180. So I can do angle 2, which is equal to 180 minus 132 minus 24, and that is going to give me 24 after I put that in the calculator. So measure angle 2 is 24. Okay. All right, so let's go ahead and take a look at number 23. I have an equal angular triangle, and they're equal angle because all these angles are congruent and they are part of this triangle. So they are equal angular. And because they are equal angular, then the sides are all congruent. And that's because we need to refer back to our pink sheets. Okay, so this side, and this side are congruent. So we can do 2x plus 11, which is equal to 6x minus 9. If I subtract both sides by 11, I have 2x equals 6x minus 20. And I'm going to subtract both sides by 6x here. 4x equals negative 20. X is equal to 5. And x is equal to 5, and that's all I need to do for this problem here. Okay? All right, so 24, I have a triangle here. Notice that we have two congruent sides. So again, by the isosceles triangle property or theorem, it says that if I have two sides that are congruent, then the angles opposite to those sides are congruent. So here's my congruent mark. Here's my arc that I need to draw. And here's my congruent mark. So I need to draw an arc there as well. So that means that this and this are congruent. So if this is 3x plus 6, then this is 3x plus 6 as well. Okay? All right, so these are all the angles. I notice that I have a right angle there. So in order for me to figure out how to solve for x, well, I need to set it equal to something, right? Again, the sum of the interior angles of a triangle is 180 degrees. So I can do 2 times 3x plus 6, right? Because there are 3x plus 6, and I just write it like that. I'm going to add 45, which is equal to 180. Okay? If I subtract both sides by 45, well, what is 180 minus 45? Let me type that in. That is going to be 135. So 2 times 3x plus 6, which is equal to 135. If I divide both sides by 2, so if I do 135 divided by 2, I get 3x plus 6, which is equal to 67.5. Wow. Oh, no, I did something wrong. This is wrong. This should be 90 degrees. I don't know why I put 45 degrees. All right, go back. Sorry, you're going to have to erase things. Okay, so 2 times 3x plus 6, which is equal to 90. Then I'm left with 3x plus 6, which is equal to 45. So then I'm left with 3x equals 39, and x is equal to 13. Okay, so that's my answer for 24. Okay, oops, my bad. Here we go, taking a look at all right, let's go ahead and do number 25. So I notice that this triangle has two congruent sides. So that means that two angles are congruent. So this and this are congruent due to the fact that by the isosceles triangle theorem, if I have two congruent sides, then the angles opposite to those sides are congruent. Okay, so if I take a look, 6y minus 2 and 4x plus 20, and I set them equal to each other because they're congruent, we have a problem. We have a variable that's dealing with y and a variable dealing with x. So we can't do anything here. We can't solve for x or y here. So we have to do something else. They are congruent, but we can't find the variable or the variables that we want, or what the values of the variables are. So what we have to do is, I know that these two angles are congruent and there's a 52. I could probably say that I could do, let's call this A, and let's call this A, right? Because I know the sum of the interior angles of a triangle is 180, I can figure out what those angles are and then figure out what my x and y values are. Okay, so we can do 2a plus 52, which is equal to 180, and 2a is equal to, let's see, 180 minus 52, that's going to be 128. And if I divide both sides by 2, I get a equals 64. So this right here is 64, right? And if this is congruent to this, this also has to be 64 as well. Okay? And the fact that 6y minus 2 is 64, I can set them equal to each other now. So I'm left with 6y equals 66. So y is equal to 11. Okay? And then over here, because 64 is 4x plus 20, I can set them equal to each other. So I'm left with 44 equals 4x. So 11 is equal to x. Okay? So that's how you do it. Number 26. Let's go ahead and take a look at number 26. So I can use the converse of the isosceles triangle theorem because I have two angles that are congruent. So the sides opposite to those angles are congruent. So I go this, and then I go that. So I have 2y plus 6, which is equal to 5x minus 3. Well, I can't do that, but what I do know is that if this is 60 and this is 60, this has to be 60 as well. Because, again, the sum of the interior angles of a triangle is 180, and it's logical that this is 60 because if this is 60 and this is 60, this has to be 60. The third angle has to be 60, right? So what that means is that because this is an equal angular triangle, then this is also an equilateral triangle. Again, go ahead and look at the pink sheets to verify that. So what does that mean? I can do, I can set this and this equal to each other. So 2y plus 6 is equal to 4 because they're congruent. So, oh, what am I doing wrong? 2y plus 6 is equal to 4. Oh, and then I'm going to subtract both sides by 6. So 2y is equal to negative 2. Y is equal to negative 1. And it's okay for your y values to be negative, but when we're talking about length in geometry, there should not be a negative length. Okay, next thing, we can take this and this. They are congruent to each other. So I have 5x minus 3, which is equal to 4. 5x is equal to, not 8, that's 7. So x is equal to 7 over 5, and yes, you might get a fraction here on the test. So I will give you a calculator, a graphing calculator to do that. All right, so that should be everything for this page here.